Hello everyone. As we know, according to de Broglie's hypothesis, a particle of mass m moving with velocity v has a wave associated with it. Now, if we consider sound waves, the quantity that varies with space and time is pressure. For electromagnetic wave, the quantity it is electric field and magnetic field. And for matter waves, that is the wave associated with the particle, the quantity that varies with psi. So Schrodinger developed wave equation for this matter wave considering the electron wave, and this electron shows the classical behavior just like the ordinary wave, and he developed wave equations, time dependent wave equation and time independent wave equation. So as psi is the quantity that varies with space and time, psi is the solution, and therefore this psi, that is the wave function, which is function of x and t, that is space and time, is equal to a into exponential. Now this a is constant. We are using exponential term because we want general waveform, and therefore instead of sine and cos we are using exponential, and we know that this wave function psi is complex quantity and therefore we have used this I. So a into exponential minus I omega t minus kx. In this equation, omega is angular frequency, which is given by 2 pi nu, and we know that E is equal to h nu, therefore we can write this nu is equal to E by h. So omega is equal to E by h. 2 pi we can take as the denominator of h, and this h upon 2 pi is reduced Planck's constant, which is denoted by h cross. So omega becomes E by h cross. Similarly k is the wave number, which is given by 2 pi by lambda. Now lambda is the wavelength of matter wave, which is given by h upon p, and this p we can take into numerator and 2 pi we can take as the denominator of h, and this becomes p by h cross. So replacing this omega and k in this equation by E by h cross and p by h cross, we get this equation 1. Psi of xt is equal to a into exponential h cross we can take outside the bracket common, so minus I by h cross omega et minus px. So this is our equation 1. Now we have 2, as it is function of x and t. First we will differentiate this equation 1 with respect to x twice. So first with respect to x, dou psi by dou x is equal to, now here a is constant, we have to just consider the coordinates of x, and coordinates of x are minus I by h cross into minus p. So minus minus becomes plus, and this becomes I p by h cross. A into exponential term will remain as it is, but this a into exponential term is nothing but psi itself, and therefore we can write this dou psi by dou x is equal to I by h cross p into psi. Here we have taken dou, since this is continuous wave function, and therefore we have taken partial differentiation. Now let's again differentiate with respect to x. So dou 2 psi by dou x square is equal to dou by dou x of dou psi by dou x, but dou psi by dou x is I p by h cross into psi. So dou 2 psi by dou x square is equal to I square p square upon h cross square into psi. I square is minus 1, so it becomes minus p square upon h cross square into psi. So from this we can write p square psi is equal to, taking this minus h cross square on left hand side, so p square psi is equal to minus h cross square dou 2 psi by dou x square, and this is our equation 2. Now let's differentiate equation 1 with respect to t. So if we differentiate with respect to t, dou psi by dou t is equal to, we have to consider the coordinate of t, that is minus I e by h cross. So minus I e by h cross into a into exponential term I have directly written as a psi, and from this we can write E psi. E psi is equal to, now taking this minus h cross by I into dou psi by dou t on the other side, but I don't want this I into denominator, so I have multiplied and divided by I. So I into I square, that is minus 1, minus minus becomes plus, and this is equal to I h cross dou psi by dou t. This is equal to E psi. And E is nothing but energy. We know that total energy is equal to kinetic energy, that is P square upon 2m, plus potential energy, that is V. Now this V is just function of x, not t. And all these are operators. E is operator, P square is operator, V is also operator. So multiplying by psi, we get E psi is equal to P square psi upon 2m plus V psi. But in equation 2 and 3, we have values for P square psi and E psi. So P square psi is equal to minus h cross square dou 2 psi by dou x square, and E psi is equal to I h cross dou psi by dou t. So putting these values into this equation, E psi is equal to I h cross dou psi by dou t. P square psi is minus h cross square dou 2 psi by dou x square upon 2m plus V psi. And now just taking this psi outside the bracket, we get this equation minus h cross square. I have just rearranged this as this has become left side, this has become right hand side. So minus h cross square upon 2m dou 2 by dou x square plus V psi common equal to I h cross dou psi by dou t. And this is nothing but the Schrodinger's time dependent wave equation in one dimension. We can extend this in 3 dimension by taking dou 2 by dou x square plus dou 2 by dou y square plus dou 2 by dou z square, which can be written as a del square, that is del operator. Okay, so this is Schrodinger's time dependent wave equation in one dimension. So we can use this equation in order to solve the problems for the particle whose energy changes with space as well as time. For example, if the particle is accelerated, then its energy changes with space and time. So in case of such particles which are accelerated, we can use this equation in order to find out the energy, wavelength and position of the particle. Thank you so much.